Hello, Advanced Math. This is lesson 9.7. We're working with inverse trigonometric functions. I just want to say I know you all are working hard. You're doing a good job. Keep asking questions when you need it. Keep plugging away. You're doing a good job. I'm proud of each one of you. So, 9.7, we're going to talk a little bit about some of the graphs of this, but mostly just the application. Most of the assignment should be fairly straightforward and I hope easy. It looks like a lot of questions, but a lot of them are just using our unit circle or our calculator. Okay, so we know inverse functions already. They are used to find an angle when we have the ratio of the sides. Okay, so the inverse sine function is what it talks about, and when we talk about inverse functions, remember that an inverse will undo something that originally done, but you have to have a specific answer. So when you have a sine function, remember there are multiple answers that repeat themselves. Okay, so when you're at 0, the sine of 0 is 0. When you're at 2 pi, the sine of 2 pi is 0. So if you go the other direction, if you say, okay, what is the inverse sine of 0? Is your answer 0, or is it 2 pi, or is it 4 pi? Which one is it? So what they've done is they've restricted it to just this interval right here. They say, okay, for the inverse sine, we're just going to use this part of the graph. And that's kind of the trickiest thing with these, is knowing where does your answer fit within this certain domain. Okay. So what happens, the other terminology, here we go, the other terminology they refer to is the arc sine. And that word arc there is like the arc of a circle. So what they're talking about with an arc sine actually comes from the unit circle when they say, okay, if they want the arc sine of 1/2, they're saying what arc has a sine of 1/2, and that would be 30 degrees or pi over 6. Okay, so that's where the terminology arc comes from. If they want the arc cosine of negative root 3 over 2, it'd be arc cosine of root 3 over 2. They're saying which arc has a cosine of root 3 over 2, and you'd say that's 30 degrees or pi over 6. So arc cosine and sine, inverse sine or inverse cosine, those are all the same things. Okay. Now also remember with inverse functions that if the domain of a function, if you have f of x, if the domain is, let's say it is from 0 to infinity, like that, and the range is from -1 to 1. If you have f inverse of x, remember the domain for an inverse comes from the range of the function. And the range of the inverse comes from the domain of the function. Okay, that's going to come into play as well. Okay. So here's the inverse sine, and what you need to know, let me scoot down, sorry, there you go. The inverse sine of a function is defined by y equals arc sine x, if and only if sine of y equals x. The domain of arc sine x is -1 to 1. So when you are evaluating an arc sine or an inverse sine, the number must be between -1 and 1. So if you'd have something like the arc sine of 4, that does not exist. Okay, that is not even in there because that's greater than 1. So this number right here has to be between -1 and 1. Okay, your answers come from the 4th and 1st quadrants. So for every arc sine, your answer has to be from -pi over 2 pi over 2, or from negative 90 degrees to 90 degrees. So if I go back to the graph that we have here, notice the domain here is from negative pi over 2 to pi over 2. The domain for this function, there we go, sorry. Negative pi over 2 to pi over 2. The range is from negative 1 to 1. So they're restricting the domain. It's going from negative pi over 2 to pi over 2. The range is from negative 1 to 1. So when you get to your inverse functions, remember those just flip. So the domain for inverse sine has to be from negative 1 to 1. The range is from negative pi over 2 to pi over 2. So the answers for every answer, and we'll talk about how this applies, but whenever you have an arc sine, your answer has to be one of these values right here. Okay? Don't use 11 pi over 6. Use negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Okay? Your sine answers will come from these two quadrants. Okay? So if they want the inverse sine of negative root 3 over 2, you're not going to say 5 pi over 3, you're going to say negative pi over 3. That's the answer. For cosine, notice the restrictions. They're restricting the domain from 0 to pi. And the range is from negative 1 to 1. Okay, so this is the domain of the graph and what they're restricting it at. So they're restricting it from 0 to pi, range is from negative 1 to 1. So when you go look at the arc sine or the arc inverse cosine, the domain, there we go, down here. Okay, the domain is negative 1 to 1 for the inverse sine, and your range is from 0 to pi. So this is quadrants 1 and 2. This one's quadrants 4 and 1. So the answers for cosine can come from quadrant 1 and 2. The answers for sine, arc sine, will come from quadrants 4 and 1. And also tangent is going to come from quadrants 4 and 1. So arc sine and arc tangent answers come from quadrants 4 and 1. Arc cosine answers come from quadrants 1 and 2. That'll be important. So every time you have one of these questions, your answer has to be a value from there. You notice for cosine, you will never have a negative value. You won't have a negative pi over 4 or negative pi over 3. You'll just from 0 to pi. All right, so if possible, find the exact value. So we have the arc sine of negative 1/2. So when you look at your chart, you're going to have two opportunities for that. Okay, so if you look down here, sine, where is sine negative 1/2? Well, it's negative 1/2 right here and right here. But you notice those answers are not in the range that we want. We want an answer from the fourth or first quadrant. So since it's negative, it's going to be the fourth quadrant. Here's negative 1/2. That's the 11 pi over 6, which we get from down here as well. But 11 pi over 6 isn't the answer. The answer would be negative pi over 6. If this is a positive pi over 6 going up, this is a negative pi over 6. So unit circle will be your very helpful friend here. So negative pi over 6 terms in radians. Okay? It'll be negative 30 degrees. So the arc sine of negative 1/2 is negative pi over 6 or negative 30. Arc sine of root 3 over 2. Again, if you look on the sine column, you're going to see it show up twice, at 60 degrees and at 120. But our answer has to come from the fourth or first quadrant. So we don't use the 120, we're going to use the 60. There's the root 3 over 2 for sine. Remember, cosine and sine. So your answer would be pi over 3. Or that'd be 60 degrees. Okay. Inverse sine of 2. This is larger than 1. Remember, your domain is from negative 1 to 1. So that does not exist. Arc cosine of root 2 over 2. So now cosine, root 2 over 2. Cosine is usually easier. Root 2 over 2, that's 45 degrees. Okay, remember, cosine is x. So there's root 2 over 2. There we go. 45 degrees. So that's pi over 4, 45 degrees. Inverse cosine of -1. Inverse cosine of -1. Okay, that does exist. That would be down here at 180 or pi. So their cosine is -1. That's 180 or pi. So it's pi radians, 180 degrees. The arctangent of 0. Now remember, tangent, it has to again from the fourth and fourth quadrants, but 0 is usually a pretty safe one. So we have 0 showing up for 0 degrees, and we have 0 showing up for 180. So these are your two, 0 degrees and 180. The one from the first or fourth quadrant would be 0 degrees. So 0 or 0 degrees. 0 radians or 0 degrees. Inverse tangent of -1. So inverse tangent, -1, shows up right here and right here. Okay, this one is 135. That's 3 pi over 4. That would be right over here in the second quadrant. Inverse tangent has to come from the fourth or first quadrant, so we're going to use the other one, 7 pi over 4, which would be a -pi over 4. You got to come down, -pi over 4. So -pi over 4 or -45 degrees would be the answer for that one. Okay, composition of functions. They are doing sines and arcsines. And this table right here tells you, okay, if I want the sine of an arcsine, it's going to be whatever you have as long as x is between -1 and 1. Okay? And if you do the arcsine of a sine, it's going to be whatever number you have there as long as y is between -pi over 2 and pi over 2, which are the range values. Okay? If they are outside this interval, then you have to use coterminal angles. So if y is outside of the given interval, use coterminal angles. Okay, and we'll look at that. So here, if x is outside the interval, answer does not exist. Remember, the arcsine of 2 or something like that does not exist. So if x is outside the interval, the answer does not exist. If y is outside the given interval, you have to use coterminal angles. Okay. Okay, so if we roll down, we have, this is what's happening here. We have the arcsine of a sine of 3 pi over 2. 3 pi over 2, this falls under this category, arcsine of a sine. 3 pi over 2 is not in that interval. So the sine of 3 pi over 2, that equals, so 3 pi over 2 is right here. The sine would equal -1. So sine of 3 pi over 2 is -1. So the arcsine of the sine of 3 pi over 2 would be the arcsine of -1. So that's where the -1 came from. They evaluated this. Okay? Now the arcsine of -1 is not 3 pi over 2 because that is not in the interval from -pi over 2 to pi over 2. So the answer here is actually the -pi over 2, so that's what they have here. It's -pi over 2. It's not going to be the same thing that you started with. Whereas if they gave you something like the arcsine of the sine of, let's go pi over 4. Okay, arcsine of the sine of pi over 4. The sine pi over 4 is in this interval. It's in the fourth and first quadrants. So this answer would just be pi over 4. It's just whatever you have there. So this property is not valid for values outside the interval negative pi over 2 to pi over 2. Same thing goes for cosine on the interval 0 to pi. So you check the domain of y given the specific function. If y is outside the domain, determine a coterminal angle to y that is inside the domain. Use a coterminal angle to complete the problem. Okay. So find the exact value. I'm going to keep this chart handy. I have the tangent of the arctangent of negative 5. So tangent is written first. So tangent of the arctangent. So if x is a real number, that means it's just going to be whatever the x value is. Okay? This part here applies to this pattern right here. So tangent of arctangent negative 5, that's just going to be negative 5. Arcsine of the sine of 5 pi over 3. So arcsine of the sine of 5 pi over 3. So this y has to be between negative pi over 2 and pi over 2, fourth and first quadrant. 5 pi over 3 is not in that interval. So what is the sine of 5 pi over 3? Well, 5 pi over 3 is right here. The sine is negative root 3 over 2. So you notice 5 pi over 3 is in the fourth quadrant, but not this amount of rotation. So we have to come back this way. That would be negative pi over 3. Okay? So this is the arc sine of negative root 3 over 2, which is negative pi over 3. Okay, so negative pi over 3 would be that answer. Hopefully you're catching all that. Okay, because we were down here. We want to be in the fourth quadrant, which we are. We just have to go with this angle. The cosine of the arc cosine of pi. Okay, so cosine comes first. Cosine of the arc cosine of x. So x has to be between negative 1 and 1. So is pi between negative 1 and 1? Is pi between that? No. So this does not exist. Okay? So pi is greater than 1. Remember, the domain here has to be between negative 1 and 1. The arc cosine of the cosine of negative pi over 4. So the arc cosine of the cosine. So I'm checking this again. Arc cosine of the cosine of y. Y has to be between 0 and pi. Negative pi over 4 is not between 0 and pi. Okay? Arc cosine answers have to come from here. Negative pi over 4 is down here. So let's evaluate this part right here. What is the cosine of negative pi over 4? So the cosine of negative pi over 4 would be root 2 over 2. Okay? So we go up here. What we're doing, we're looking for another cosine that equals root 2 over 2 in the interval that we can get our answer from. So the arc cosine, remember root 2 over 2, there's another one. Here's the one that we have. Okay, negative pi over 4 is down here. That is 7 pi over 4. There's another one up here at pi over 4. So you notice the overlapping values here. So what this ends up being is the arc cosine of, remember, root 2 over 2. Now if you evaluate that, you have to use answers from these top two, which would be pi over 4. Okay, so this chart, check with this chart first, and then if arc is written first, if the arc sine, arc cosine is written first, make sure you're checking with your unit circle, and your answers are coming from the appropriate quadrants. Okay, use an inverse trigonometric function to write theta as a function of x. So, which ratio do we need? This is theta, this is opposite, this is adjacent. So we need tangent. So theta equals the inverse tangent of x over 4. That's it. Okay, just kind of your definition, what you know already. So theta equals inverse tangent of x over 4. This is opposite, this is hypotenuse, so we're going to use sine. Theta equals inverse sine of x plus 2 over 5. You have written an inverse trigonometric function as a function of x, because x is part of the original function there. Those are pretty nice. Okay, find the exact value of the expression. Hint, sketch a right triangle. So, I'm going to come down here, have some more room. The sine of the arctangent of 3 over 4. This is number 1. So arctangent, this is the opposite side. This is an adjacent side for a triangle. So I'm just going to draw a right triangle. It doesn't have to be to scale. This is my angle, theta. So opposite has to be 3. Adjacent has to be 4. So adjacent's going to go right there. Opposite's going to go right there. And then they want the sine of that. Okay? So this tells you how to draw the triangle. So you're going to use this to label two sides of the triangle. Okay? That's what you're going to use that part for. So each of these, that's what you're using. And then find the third side. So if it's 3, 4, that has to be 5. And then answer the question. So the sine of theta would be opposite over hypotenuse, 3/5. Sine of theta would be 3/5. Okay? So we're going to use this to write a triangle. So there's theta. Arctangent 2 over 1. So that's opposite over adjacent. So that's 2 over 1. 2 over 1, 2 squared plus 1 squared, that gives us the square root of 5, Pythagorean theorem. Okay, so your cosine would be adjacent over hypotenuse. So the cosine of theta would be 1 over root 5. Rationalize the bottom, you get root 5 over 5. Okay. The secant of the arctangent of negative 3/5. Okay, so what we have here, the arctangent is going to be negative, which means we are either in quadrant 1 and quadrant 4. I'm not sure if I made this one up or... let me check the assignment. Okay. Yes. Oops. Don't want that, sorry. You need to look something up here because that negative there, secant of the arctangent. Okay. Negative 3/5. Where does that negative go? Which quadrant are we in? Because that would be opposite over adjacent. And you do have one kind of exactly like that. Okay, let me pause this somehow. I can figure something out. Okay, I'm back. Finally dawned on me that, remember the arctangent, whatever value this is, your answer, these answers come from the fourth and first quadrants. So when you have this, your answer is going to be a fourth quadrant angle. I'm not going to draw that one right there. I'm going to draw more one that's going down like this, and this is going to be theta. Okay, opposite over adjacent, so this is negative 3 over adjacent, which is going to be 5. So if you have an arctangent, this is number 22, this is your last one, very similar, they're just saying a cosecant instead of a secant. So arctangent, if this is negative, remember your answer has to be in the fourth quadrant. If you'd have an arc cosine that is negative, you'd have to be in the second quadrant. Okay, so 5 and 3, so that's the square root of 25 plus 9, which is square root of 34. So they want the secant. Secant is the reciprocal of cosine. Cosine is x over r, or adjacent over hypotenuse. So secant is going to be r over x, so that's going to equal root 34 over 5. That would be positive, okay, because cosine is positive in the fourth quadrant. So the secant of the arctangent of negative 3/5. This is negative tangent. If this is negative, tangent answers have to be in the fourth quadrant. In the fourth quadrant, cosine answers would be positive. Now, if this was a cosecant, if I wanted the cosecant of the arctangent of negative 3/5, now I would have to do this opposite over hypotenuse, or hypotenuse over opposite, and that would be negative root 34 over 3. That one would be negative, because you're in the fourth quadrant. Okay, I will answer any questions you have on that. Again, 22 questions. A lot of them are, you're just looking off the coordinate plane, or the unit circle. So all of these right here, wait a minute, you don't need to see all that. All of these right here, you're going off the unit circle. Okay, all the way through question 8. Question 9, it says just use a calculator. Arc sine, you're using inverse sine, inverse cosine, inverse tangent. Just plug them in the calculator. Write a trig function. Theta is a function of 0, so you're deciding, okay, that's arc cosine of x over 4. So inverse cosine x over 4. These are the composition of functions. And notice these will be the same tangent, arctangent, sine, arcsine, up until here. Now you have to start drawing those triangles. So these last three, you're going to be drawing those triangles like we just did for the last 3 examples. Okay? Good luck. Hang in there. Keep working. Keep studying. I'll see you soon.